All right. So, again, we're about halfway through section 5.4, and you're actually going to see the second part of the fundamental theorems before you see the first part, and the reason for that is the first part's a little harder. It's more abstract. This is all about practice. In fact, a lot of people call this the integral evaluation theorem. What it tells you how to do is take an integral and associate a number with it. So, we've had one quick look at this, but here it is formally for the first time. If you've got a function, f, I should say f prime, is continuous over the interval on a to b, and f is the antiderivative of f prime, then to find the integral from a to b of f prime, simply calculate f of b minus f of a. In other words, take the antiderivative, plug in the upper limit, take the antiderivative, plug in the lower limit, and subtract between them. I know we've done some examples of this in the past. Now it's just the day that you have to know it from here on out. Another way that this is written, this is the confusing way that it's often written, they say little f is the function we're going to integrate, and they call its antiderivative capital F instead. So instead of calling it, giving it a derivative name, they just say this is some function f who's got a big brother or an antiderivative capital F. Do note the continuity is important. You cannot integrate discontinuous functions, although there are means by which it can be done. So, if they're not calling this a derivative, then they're going to use a capital letter on the other side. This tends to be confusing to people, but all it says is capital F is the antiderivative of little f. So, take the antiderivative, plug in the upper limit, take the antiderivative, plug in the lower limit, subtract the quantities. All right. So the solution here will represent the area under the curve. Remember, these answers can be negative and off and on. So let's use the fundamental theorem to evaluate cosine from 0 to pi over 4. So the first thing I need is the antiderivative of cosine. Try again. Positive sign. So what we're going to do, now that we have the antiderivative on paper, we're not going to write the integral symbol anymore. We're going to put a bar on the right, and we're going to say we're going to evaluate this from pi over 4 back to 0. Once you have your antiderivative, get rid of your integral symbol. So this becomes the sine of pi over 4 minus the sine of 0. The sine of pi over 4 is 2 over 2. Sine of 0 is 0, and this integral turns out to be square root of 2 over 2. Now, I'm not going to send you an answer key to today's homework, because every one of them is a definite integral, and you have a calculator, and practice on the calculator is every bit as important as being able to do it without a calculator, so that's how you'll check it. There are instances when the calculator gets the wrong answer, or it gets a different answer than you get. The calculator won't get it wrong. You might get an answer that seems perfectly legitimate, and the calculator will tell you this didn't work. I'll show you an example in a minute. Another thing to mention is 0 is a wonderful limit to work with because it's so easy to substitute in. And you studied odd and even functions last year. There's a reason for that. The reason is, if you have a good understanding of odd and even functions, a lot of integration problems are simplified. Tell me the integral from negative pi over 4 to positive pi over 4 for cosine. It's based on the top problem. Luke? Is cosine an odd or even function?
Odd. Even.
Cosine's an even function. It's got y-axis symmetry. So if the first region from 0 to pi over 4 had area root 2 over 2, wouldn't the region from negative pi over 4 to 0 have that same area? So when I combine those, I end up with root 2. Take note, if you have 0 as a limit, or if your upper and lower limits are opposite values, stop to visualize the graph. You might save yourself a bunch of work along the way. Okay, here's a really basic example. Find the area under the curve, negative 6x plus 6, on the integral from 0 to 1. Again, all we're talking about here is a triangle. If I draw negative 6x plus 6, simply a triangle. The line y equals negative 6x plus 6 would have a y-intercept of 0, 6, and a root at 1, 0. The length of this triangle is 1. The height of this triangle is 6. The area turns out to be 3. But let's use the antiderivative technique to calculate it. Antiderivative of negative 6x, negative 3x squared. The antiderivative of 6, 6x from 0 to 1. I'm going to plug the 1 in, and I'm going to get negative 3 plus 6, and then minus, plug the 0 in, I get 0 plus 0. And yes, we do end up with an area of 3, exactly as the triangle had predicted. Go ahead.
For that one, do you, like, does it not matter if you put the plus c at all?
Great question. You never have to put the plus c in a definite integral. Stop and think, had I put the plus c in, the next step would have either been try to figure out what c is, or just ignore it and continue on, right? Well, had I put a plus c right here, there would have been a plus c here and a plus c here, but this c minus this c would have wiped it out completely. So, yeah, great question. I'm glad you brought that up. You never have to deal with the constant of integration in a definite integral.
Awesome.
Anything catch your eye here? Split it up. Integral from 25 to 36. Give me another way to write 1 over the square root of x. X to the negative 1/2, and then minus 1 dx. What's this? The antiderivative of x to the negative 1/2.
Or 2
Add 1 to the power, that takes me to the 1/2. The reciprocal of the new power is 2, and then the antiderivative of 1 is x. We're going to evaluate this from 36 to 25. So we're talking about 2 square root of 36 minus 36 in parentheses minus 2 square root of 25 minus 25. Of course, you're done at this point. Unless it's multiple choice, there's no requirement that you simplify this. 2 square root of 36 is 12. 12 minus 36 would be negative 24 minus 2 square root of 25. 10. 10 minus 25 is negative 15. We end up with a value of negative 9. Get in the habit of checking your work on the calculator along the way. It's not hard, is it?
No.
Sometimes the antiderivatives are a little harder than others, but it's a matter of plugging values in. Like Lauren said earlier, there's a focus element here because you got to get your things right, but the concept isn't terribly hard. Yes?
What is the thing that you do to find an integral in the calculator?
Math 9.
Math 9.
Yep. Find it?
Yep.
All right. So now I throw this up here, and this to me looks like a really easy problem. Integral from 0 to pi of secant of x times tangent of x dx. All right. Well, what's the antiderivative? Secant of x. Because I now have the antiderivative, no more integral symbol, 0 to pi, end up with secant of pi minus secant of 0. What is the secant of pi? Negative 1 minus 1, and that turns out to be negative 2. And then, because I'm in the habit, I want to check this on my calculator. Let's check it on the calculator. Y equals, so it's tangent of x times secant would be the same as divided by cosine. And let's go back. Integrate from 0 pi function 1, and the variable here is x, domain error. What's that? Secant tangent isn't a continuous function on that interval. Secant tangent has vertical asymptotes at pi over 2. Cannot integrate across a vertical asymptote.
Is there a way to recognize that
It
before?
doesn't have an answer. Yeah, this is undefined or fails to exist.
How do you know that from just doing the work?
You don't. Well, see, the thing is, the condition of the theorem says, if the function is continuous, then this is what you should do. If the function isn't continuous, don't do that.
So you just gotta know. So you just have to know.
You have to examine. You have to examine your function for continuity before, and there's that concentration thing, right? Because whoever thinks to do that, nobody does. Nobody. Now, and here's what makes it a little worse. There are instances where you can get away with integrating across a discontinuity.
Because if you on the interval.
There's always two conditions.
For instance,
No,
You can factor it.
you can't do that.
this is a discontinuous function, and the discontinuity is at 4. But what kind of discontinuity is it? It's removable. It's a hole. So that's not going to cause me a problem in an integral. I'm not going to lose any area under that hole. However, this is still a horrible antiderivative, unless, as Christian said, you factor it. And then it turns out to be the integral from -4 to 4 of x plus 4, -4 to 6, I'm sorry. And you can, of course, do that as a geometry problem. I think you're looking at a trapezoid. Or you can go with 1/2 x squared from -4 to 6. Wait a minute. 1/2 x squared plus 4x from -4 to 6. So it can be done. You can get away with integrating over a removable discontinuity. A vertical asymptote, you're not going to get away with that. All right. We're doing well. We're doing well. Let's evaluate the integral from 0 to 4 of x cubed minus 16x. Antiderivative of x cubed is 1/4 x to the 4th minus 8x squared from 0 to 4. So that's 1/4 of 4 to the 4th minus 8 times 4 squared minus 0 minus 0. The liberal use of parentheses here is a great idea. Don't use too few. Thought I was for a minute. All right. 4 to the 4th divided by 4. What is it? Is it really? It's actually 4 cubed, isn't it? That's 64. Minus 8 times 16, minus 128. Am I on the right track here? Minus 0 gives me an integral value here of negative 64. All right, let me draw a quick picture. We know what x cubed minus 16x looks like. X cubed minus 16x. Well, that's x times x plus 4 times x minus 4. It's a cubic. I know the roots. And we just found this area to be negative 64. Anybody want to give me the integral from -4 to 0 of the same function?
64.
Positive 64. So now based on that, can you tell me the integral from -4 to 4? 0. How did that happen so quickly? What kind of function am I looking at? an odd function. Another thing I always want you to keep in mind, when these numbers are opposites, examine a little more closely. This turns out to be 0. Now you can get that 0 going through the whole amount of work. You're going to end up plugging a negative number in, and keep in mind there's a negative sign here. You're bound and determined to make a sign error along the way there. Okay, so when you're given a problem that's just an integral, that's going to give you an answer. That answer represents net area. It could be a positive number, it could be a negative number, it can be 0. However, if you're asked for the area between the curve and the x-axis, all regions are going to be regarded as positive. I brought this up before, I can keep stressing it. So when you're asked for an area between curves, or total area, then everything has to be counted as positive. So another question I can ask is, find the area between the curve, x cubed minus 16x, and the x-axis. Well, that's that same graph. This area was negative 64, this area was positive 64, but what's the answer to the question at hand? 128. I've got these two bounded regions between negative 4 and 4, and the area between the curve and the x-axis is that stuff. Okay, now I want to show you just 3 more quick examples. This came off the 2012 AP exam. This should have been the easiest question on the whole test. Ooh, and it wasn't. Question number 1, it's a non-calculator question. Using the data in the table, evaluate the integral from 0 to 20 of w prime. Using correct units, interpret the meaning of that. Now this is, they want me to integrate w prime. Well, I like that. I like to integrate derivatives. And the table is giving me w. That's all I need. What is the integral from 0 to 20 of w prime supposed to look like? W from 0 to 20, it's w of 20 minus w of 0. Those two values are in the table. 71 minus 55. What's that? Yeah, I do too. I had a hard time with that question. Because when people are asked to integrate, you know what they look for? They look for a function. I don't have the w function. There's no x cubed minus 16x to work with here.
And they panic for 5 minutes.
Yeah, I'm panicked. I'm like, I don't have enough information to do this problem. I don't have the w function.
They give you all that extra information. That's just confusing.
Sure, sure. And of course, they want the meaning of that. Let's go back to an old sentence. The integral of the rate of change of w yields the net change in w. The integral from 0 to 20 of w prime would yield the net change in temperature measured in degrees over 20 minutes. And of course, you had to tell them it was over 20 minutes, and they asked for the correct units. They would want degrees Fahrenheit.
They had 1 over 20 in front
How
of
many
it would
points
be
is that?
average.
If it were 1 over 20 in front of it, it would be, that would be the average value of w prime though. So that would be the average rate of change. It would be the average value of the rate of change. How many what? I think it was 2. 1 for the numerical answer and 1 for the interpretation of the meaning.
That's just part B though.
But that's just part B, right? Okay. There it is. 1 for the numerical value and 1 for the interpretation of the meaning. So again, notice they had the numerical value, and then they said the water temperature has changed. That's the meaning of integral, net change, and then 0 to 20, and they gave the units as well. Okay, now we've already done this problem once today, sort of. The graph of f prime, the derivative of f is the line shown in the figure above. F of 0 is 5. Find f of 1. Now, this line is the line y equals negative 6x plus 6. So what happens here is this turns out to be one of yesterday's homework problems. I've got an initial value. So if I did the antiderivative, and by the way, this is f prime or y prime. The graph of f prime, the derivative of f is the line show. So if I integrate this, I get f equals negative 3x squared plus 6x plus c, and then they tell us f of 0 is 5, so 5 has to equal negative 3 times 0 squared plus 6 times 0 plus c. What is this constant? 5. Now find f of 1. Negative 3 plus 6 plus 5 gives you 8. Why did I bring that problem in here today when that should have been in yesterday's homework? Try this. The integral from 0 to 1 of f prime, in this case, turns out to be, remember the area of this triangle from way back at the beginning of the lecture? Turned out to be 3, right? So what that tells me is from 0 to 1, the function changed by 3 units. If it's 5 and it's going to change by 3 units, where does it end up? At 8. What's that? This is much easier if you practice this. What's that?
Too much of a
Not a coincidence at all. Okay, how would you integrate something like that? Annie?
Not last. If we were able, like, what would we do if we weren't able to recognize it was negative 6x plus 6x?
Well, I'll tell you what. The intended solution of this problem was this one.
I'll do it that way.
Yep. The intended solution was this one. And let me show you the intended solution worked out. I kind of talked through it, but here's what it actually looks like. The integral from 0 to 1 of f prime of x should equal f of 1 minus f of 0, shouldn't it? Well, this is asking for the area of the triangle. That's 3. F of 1 is the unknown, and f of 0 is given as 5. So what did this problem depend on? Yesterday we would have done it as a initial value problem. If you recognize it, it's much easier as a fundamental theorem of calculus problem. And these are really common. In fact, we'll spend a whole day on that not soon. It's one of the last things we do right before the AP test. We spend a whole day on problems of this nature because they're so prevalent on the AP test, and they're so easy if you recognize them. All right, a couple more quick ones. How would we go about finding the area of this thing from 0 to 21? Split it up. My first integral would be of x cubed. What would the limits be? 0 to 1. And my second integral would be of 5x minus 4, and my limits would be 1 to 21. That's not bad. So let's close it off with one last problem. From 2011. Show that f is continuous. Boy, it had been a long time since we had talked about continuity when this thing came up. Left limit at 0, right limit at 0, y coordinate at 0 have to be the same. Express f prime as a piecewise function. Find f prime at negative 3. The big question is, does the bar come with? We'll be good at that by then. But now here's the tough one. Find the average value of f on negative 1 to 1. So I'm looking for 1 over 1 minus negative 1 times the integral from negative 1 to 1 of function f. Say it louder. function f is two functions. Well, it's one function with two pieces, right? So what I really have to do is take half of the integral from -1 to 0 of 1 minus 2 sine x, and to that I have to add 1/2 of the integral from 0 to 1 of e to the -4x. Now, this was question 6 in the free response part. This was the last question. How's your concentration now? Yeah, this is, you are spent at this point. So, I've got a -2 right here in front of a cosine. Is the antiderivative of negative sign positive cosine or negative?
Negative.
It actually is.
Yeah, I was thinking because it's negative.
Antiderivative of 1 is x. I'm just going to bring the -2 along. The antiderivative of sine would be negative cosine from -1 to 0. Now, how about the antiderivative of e to the -4x? Well, that's e to the -4x multiplied by -1/4. So it got a little messy, and that's a hard way to finish. Yeah, especially at that moment in time. Now,
How do you know it's the addition between the two piecewise functions?
well, you have to consider what this curve would look like. 1 minus 2 sine of x would be some sinusoid over here on the left, headed for the point 0, 1. And then e to the -4x, that's e to the 0. It's going to be some sine curve, or some exponential curve, headed off to the right. And if I start at -1, I'm going to have this type of region, and go from 0 to 1, I'm going to have some other region. To get the total, I'm going to have to integrate them separately. So yeah, that was a really hard way to finish out the test. And of course, if you see the correct answer, which I don't think I have on here, darn it, you would look at that answer and say, there's no way this could be right, because it's just some big long mess of numbers.
Right.